Okay, so we're going to do closure problem 2-171. For each equation, give the locator point hk and the equation of any asymptotes, and then draw the graph. So in this first equation, f of x equals negative absolute value of x plus 2 minus 1. I know it's an absolute value, so there's no asymptotes. This value here is giving my h. Since it is plus 2, I'm really doing x minus negative 2 because it's always x minus h, giving an h value of negative 2. And then this value over here is our k value, negative 1, meaning my locator point is at negative 2, negative 1. So I'm going to go ahead and plot that. Negative 2, negative 1 on the graph. An absolute value is a V shape, and I can see that this V is going to open downward by the negative out front. Since it's a negative 1, that means my slope is really 1 on each side. And you can see that I'm going down 1 over 1 on each side to create a V graph. And that's it for the absolute value. In B, here I have a hyperbola, which means there are asymptotes. The general equation is y equals a times 1 over x minus h plus k, where h and k are the asymptotes. Since here I'm not subtracting anything from the x, that means my h is really 0, which means the equation of one of my asymptotes is x equals 0. So I'm just going to write asymptotes here. One of them is x equals 0. Let's go ahead and plot that. I always show my asymptotes with a dashed line and arrows to show they continue. My k value is 2, meaning y equals 2 is my horizontal asymptote. So at 2, I'm drawing a dashed line through that y value and arrows to show it continues forever. The nice thing about this hyperbola is where the asymptotes intersect is our hk. And now I can go ahead and graph this. I know that from the locator point, up 1 over 1 and down 1 over 1 gives me my first set of points, and then they curve in and get closer and closer to the asymptotes. And that's the graph of the hyperbola. All right, let's look at C and D. For C, this is a hyperbola again, so I can see that my asymptotes are going to be from this h and k. Since k is negative 2, I have an asymptote at y equals negative 2. Since I have plus 5, that means h is negative 5, so x equals negative 5 is my vertical asymptote. So let's go ahead and plot these. Negative 5 for my x value, and negative 2 for my y value. There's my asymptotes. And just like the previous graph, I'm going up 1 over 1 from each corner because my stretch value is just 1. I'm curving those lines to show that they're approaching the asymptotes but never actually reaching them with arrows to show that as well. Finally, for this graph, I have a negative. Nothing is subtracted from the x to have an h value of 0, and plus 5, meaning my locator point is at 0, 5. Let's go ahead and plot that right here. Negative means that it's going to curve downward as x increases instead of upward like the parent cubic graph. So I'm at negative 1, 6 and positive 1, 4. And I can plot a couple of extra points. You see how now it's curving downward and then upward, making a nice S curve. And that is how we can graph transform functions based off of h and based off of k.